Okay, so now we're going to talk about one of the most common applications of these multi-component phase diagrams, these temperature composition diagrams, and that is for distillation purposes. Okay, so we'll talk about the idea of fractional distillation here. You're all pretty familiar with the concept of distillation from your organic chemistry laboratory activities. Okay, so we're going to see how these temperature composition diagrams kind of explain the process of distillation. All right, so let's start with a situation where we have a mixture that is 0.1 mole fraction in A. Okay, so let's start with a pretty dilute solution in A. Okay, so we want to make more A. Okay, let's say that we want to try to isolate a higher concentration of A in this process. All right, so what we can do is to heat up our 0.1 mole fraction mixture in A. Okay, remember we are going to start to form vapor once we hit that line, that bottom line. Okay, if we draw the tie line there, that first vapor that comes off is going to have a higher composition in A than we started with. Okay, so we're going to have an enriched vapor here. Okay, so that first vapor that comes off is enriched in A in comparison to our starting solution. Okay, so what we can do now is we don't want to keep heating that, right? That won't change the composition of our mixture, right? It would just stay at that slightly more enriched composition of A if we continue to heat. But what we can do is to condense that vapor, so we can isolate that vapor and condense it. Okay, so we're going to condense, and then we'll have our liquid phase that is enriched in the mole fraction of A. And then we have now a new vapor that is going to be even further enriched in A. And then we can condense that. We have a new vapor, even more enriched in A. And then we can kind of continue that process till we get, essentially, we can isolate pure A with this process. Okay, so we get our enriched vapor, and then these vertical lines here are going to be where we condense our enriched vapor at every step. Okay, so this is the idea behind fractional distillation. This is a multi-step distillation process. Okay, so you probably did a simple distillation where you just did a one-step distillation. In organic chemistry, fractional distillation would involve a special column that has essentially different gradients of temperature. Okay, so as you go higher up in your, so if we have a distillation column here, so as you go up in your distillation column, your temperature decreases. So we start off warm where we're heating our solution, okay, and as that vapor kind of floats up here, that volatile vapor floats up here, it gets cooler, and that's where you can kind of isolate the different compositions of vapor along your column. Okay, so each one of those steps that you might be interested in, so you can have different numbers of steps in your distillation depending on how pure you want to get your volatile component. Okay, we call those steps plates or a fraction. Okay, so each step you'll hear referred to as a plate or a fraction. Okay, so if you ever go on a tour of a distillation factory or distillery, okay, where they make spirits like whiskey or vodka or anything like that, you'll see that the stills they use will have all kinds of, they'll be really tall and they'll have a bunch of different windows in them, so they'll look kind of like this. Okay, and so each one of those would represent a plate where they distill. All right, so that's the idea behind fractional distillation. Again, just heating, getting that enriched vapor and condensing, and then getting that enriched vapor and condensing again, and then that enriched vapor and condensing again, and so on until you get a mole fraction of your volatile component that you are desiring.